Hey guys, welcome back to the channel, and in today's video we're going to go over this bad boy, which is my custom designed fully or semi-fully 3D printed single shaft shredder. Now let's go over some of its features, and I'll show some features in CAD on screen right here as well. Alright, so the first main point here is that it's a single shaft shredder, meaning only one shaft of blades is spinning and it will cut against the set of fixed blades. Secondly, thanks to the advantages of 3D printing, I am able to incorporate a mesh to control the size of the particles that come out. You can see they can be secured with some nuts that will be slotted in here, and then a screw that will be placed in their corresponding slot. Alright, that brings me to the next feature of this shredder, which is minimal hardware. The only hardware required are two shaft colors, which can be 3D printed as well, 8 sets of nuts and bolts, and simply 2 bearings. And along with that, which is a nice segue, this provides really easy disassembly. This video is sponsored by PCBWay. Whether you need high-quality PCBs, CNC machining, 3D printing, or injection molding, PCBWay has got you covered. Their fast turnaround and great pricing make them my go-to for prototyping and custom parts. Check them out at PCBWay.com, link in the description.
A few moments later.
And that's all there is to disassembling it. Now, one thing to point out is that this is a hexagonal shaft, which is really nice because it allows for 3 positions of orientation. Unless if you failed geometry class, which I did, you can probably tell that there's only 3 positions. You have, for example, 0 degrees, and then you can turn it 60 degrees, and then you can turn it 120 degrees, and then you'll turn it 180 degrees, which is back to 0 degrees, because if you rotate something 180, then that means it's like flipping it over on its side, and since this is a two-toothed, whatever, blade, then it will simply be only 3 configurations. Another great advantage of this fully 3D printed shredder is that you can have custom blade geometry. Of course, you're not going to want to print your blades out of really weak PLA, but if you print them out of, for example, ABS or some really durable material, depending on what you're going to be shredding, you're going to want to have to change the shape and style of your blades. For example, if you want multiple teeth, for example, if you want 5 teeth on a blade, or if you only want 2. In my instance, I only did 2 due to the simplicity of the design. And one more key note to point out, and you should try to implement this in your designs if you haven't already, is the fact that all of these are print in place with minimal supports. You can see that these blades are simply printed flat like this. These front panels are printed flat as well. Very simple geometry. And these fixed blades are probably the most tricky part. But for these nut slots, you can utilize the printer's overhang printing capabilities, as well as the 45-degree angle that you can see the nut will slot into, like so. Like the 45-degree angle. And also, how it's printed is that instead of printing it like this, with this part on the bed, this area needing support, I flipped it over so that it's a more gradual increase, so that the printer can handle the almost 45-degree overhang, and then the rest can be easily printed. So that's another pro of 3D printing, because it allows you to have entire pieces that enable the easy assembly and disassembly. Unlike the laser cut or CNC milled parts, you have to have, for example, a rod, and then you need to attach each individual portion of the fixed blades, which will cause a lot of confusion and ultimately increasing the price of the shredders. in total, I would say this entire thing, if you count the printed parts, would be less than $3 in raw PLA with very strong settings. Assuming you found some bargain filament to print with, and the hardware, the total would be almost probably under $5. Now, I'm gonna do a little bit more research, so I'll put the exact total on the screen right here, but you get the idea that these shredders, when utilizing additive manufacturing, can be quite easy to make. But now you may be wondering, Aaron, what the heck are these supposed to shred? And I say, definitely not metal. Okay, I'm not funny, but obviously, since these are plastic shredders, they're not as durable to shred large steel parts or something like that. In fact, you might be able to get away with shredding some thin aluminum. The YouTube channel Let's Print was able to shred aluminum cans using their fully 3D printed shredder. Of course, the design is a little bit different, but you get the idea. Plastic blades all have great potential. Now, the ultimate goal of these shredders and this shredder project is to shred two things. The first is paper. Now, this shouldn't be too difficult.
Famous last words.
Because paper is relatively easy to work with. Although it's quite structurally strong, it comes in thin sheets, so it's unlike shredding wood, it'd be a lot more easier to manipulate, so thus making the shredding process easier. Second of all, I want to work on shredding plastic. With plastic, yes, you heard me right. The ultimate goal of this is to create an infinite, or not quite infinite, but a perpetual recycling loop where you can use desktop extruders, or for example, a mold to cast out parts out of failed prototypes, which, if you don't know me, I have a lot of. And that's not it. Because along with this single shaft shredder, and if you saw in the last video, it didn't shred very well. And that's why I wanted to switch to a dual shaft shredder. And this is a sneak peek, by the way. So definitely stay tuned for more updates and more progress on these projects, because they'll definitely be worth it. Thank you so much for watching, and I really do appreciate all the attention that you're giving me. I know it's hard to listen to some random guy yap on the internet when you can be playing Fortnite right now. So seriously, I appreciate it. And one last thing, I'm right now starting an initiative called Operation Perpetual Printing, and the goal is to create easy access for small businesses, classrooms, hobbyists, makerspace, and even random Joe Schmoes like you and me to have easily to make recycling systems that can empower recycling and sustainability for everyone. Because, to be honest with you, shredders shouldn't cost however much money they cost nowadays, with paper shredders being around $50 to $100 and real industrial shredders being way more than that. They become inaccessible, and when you want to build one yourself, they become hard to build with all the infinitesimal pieces and assemblies and hardware and this and that. It becomes a little bit too complicated for the average person. So that's why I'm trying to create a system of shredding where we can recycle plastic and keep the plastic out of our oceans and out of the fish's mouths. So in the description, you'll find two links. One link is for the website, and the second is a page where you can support the movement and donate to me to help me on my journey of ending plastic waste for everyone. And of course, it's going to be a long journey, it's going to be a hard journey, and it's going to be a journey where a lot of people are involved, and a lot of makers, hobbyists, and schools and makerspaces are involved, but I believe we can do it. For transparency issues, I believe that all transactions should be open to the public. That's why I've set my setting so that all transactions created by me and you, donations or expenses, can be viewed by anyone anywhere. That way, you'll be assured that your funds will go towards the impact, and not just some random money laundering scheme. In short, I have some really big goals for this project, and I would really appreciate if you'd help me out, and if you can, support me with $5 or $2 or anything that you feel is necessary and would help me with this movement. And most importantly, I want your passion in this movement. If you can't donate, maybe try to recycle more. Instead of throwing your plastic bottles in the trash, put them where they should be, in the recycling bin. Maybe start a recycling program in your makerspace or in your school. The little things add up, and I believe we can make a really great impact. Alright, that's enough for today. Thanks for watching, and I'm out, y'all. Peace.